A butterfly called Mercury. Poincaré wasn't able to answer the King of Sweden's question about the solar system, whether it would remain in a stable equilibrium or might fly apart in a catastrophic exhibition of the chaotic motion. His discovery that some dynamical system can be sensitive to the small changes in the data opened up the possibility that we may never know the precise fate of the solar system, which in advance of any potentially devastating scenario unfolding. Sure, it is possible that, like population dynamics with a low reproductive rate, the solar system is in the safe predictable region of the activity. Unfortunately, the evidence suggests that we can't console ourselves with a comforting mathematical hope. Recent computer modeling has provided new insight which reveals that the solar system is indeed within a region dominated by the mathematics of chaos. Mathematics of chaos, really? It means solar system could be broken down at any moment, right? I can measure how big an effect a small change will have on the outcome using something called the Lyapunov exponent. For example, in the case of billiards played on the differently shaped tables, I can give a measure of how catastrophic a small change will be on the evolution of a ball's trajectory. If the Lyapunov exponent of the system is positive, it means that if I make a small change in the initial conditions, then the distance between the paths diverges exponentially. This can be used as a definition of chaos. With the measure, several groups of the scientists have confirmed that our solar system is indeed chaotic. They have calculated that the distance between the two initially close orbital solutions increases by a factor of 10 every 10 million years. Wow. This is certainly on a different time scale to our inability to predict the weather. Nevertheless, it means that I can have no definite knowledge of what will happen to the solar system over the next 5 billion years. If you are wondering in the despair whether we can know anything about the future, then take heart in the fact that mathematics isn't completely hopeless at making predictions. There is an event that equation guarantee will occur if we make it to 5 billion years from now, but it's not good news. The mathematics implies that at this point, the sun will run out of the fuel and evolve into the red giant, engulfing planet Earth and the other planets in our solar system in the process. Wow, engulfing. But until this solar blowout engulfs the solar system, I am faced with trying to solve the chaotic equations if I want to know which planet will still be around to see that red giant. This means that, like the prediction of the weather, if I want to know what is going to happen, I am reduced to running simulation in which I vary the precise locations and the speeds of the planets. The forecast is in some cases rather frightening. In 2009, French astronomers Jacques Lascar and Michael Gastineau ran several thousand models of the future evolution of our solar system. And the experiments have identified a potential butterfly. Mercury. Wow. The simulation starts by the feeding in the records we have of the positions and the velocities of the planets to date. But it's difficult to know these with 100% accuracy. So each time they run the simulation, they make small changes to the data. Because of the effect of the chaos theory, just a small change could result in a large deviation in the outcome. For example, astronomers know the dimension of the ellipse of the Mercury's orbit to an accuracy of several meters. Lasker and Gastineau ran 2,501 simulations where they varied these dimensions over a range of less than a centimeter. Even this small perturbation resulted in the startlingly different outcomes for our solar system. You might expect that if the solar system was going to be ripped apart, it would have to be one of the big planets like Jupiter or Saturn that would be culprit. But the orbit of the gas giants are extremely stable. It's the rocky terrestrial planets that are the troublemakers. In 1% of the simulation that they ran, it was tiny Mercury that posed the biggest risk. The models shows that Mercury's orbit could start to extend due to the certain resonance with Jupiter, with the possibility that Mercury could collide with its closest neighbors, Venus. In one simulation, a close miss was enough to throw Venus out of the kilter, with the result that Venus collides with the Earth. Even close encounters with other planets would be enough to cause such tidal disruption that the effect would be disastrous for life on our planet. This isn't simply a case of abstract mathematical speculation. Evidence of such a collision has been observed in the planet orbiting the binary star Upsilon Andromeda. Their current strange orbits can be explained only by the ejection of the unlucky planets sometimes in the star's past. But before we head for the heroes, the simulations reveal that it will take several billion years before Mercury might start to misbehave. Sure.